Chapter 8 is all about similar figures. It starts with similar polygons, and then we narrow it down to similar triangles. So in 8.1, it's just similar polygons. Okay, so this could be triangles, this could be squares, this could be quadrilaterals, this could be any kind of polygon. And if two polygons are similar, then their corresponding angles are congruent and their corresponding sides are proportional, meaning they don't have to be the same, but the ratio of the matching sides will all simplify to be the same thing. So a similar polygon is like a little mini version of that polygon or a bigger version of that polygon. It will have the same overall shape. It could be rotated, so it doesn't always necessarily face the same way, but it will have the same overall shape, and all the angle measurements will be congruent, and all the sides, when set up in a ratio, would simplify to be the same thing. So in this diagram, you can say that A, B, C, D is similar, and this little symbol, that like squiggle, is how we use similar, so they're not equal or congruent, they are similar, to M, N, O, P. And the order of the letters is important. The first angle that's mentioned, so the first letter here is A, would be congruent to M. At B would be congruent to N, C would be congruent to O, and D would be congruent to P. So the order of the letters is important. Good morning. All right, so angles are the same, and again, order is important. If I rotate around the A, B, C, D, then obviously if I want to keep it in the same pattern, I'd have to rotate the M, N, O, P, okay? And then the sides are proportional, so again, order matters. Like if I do A, B, it has to go over MN because those are the first two letters that are mentioned. BC would go over NO, CD would go over OP, and AD would go over MP. So the order of the letters is important. And you're going to get this in two different ways. One, it will say these are similar. Find the pairs, and so you'll either list out all the angles and the proportional sides, or it will say given the side lengths or whatever, are these similar? And in that case, you would have to put all the corresponding side lengths over the other ones and make sure they all simplify the same thing. So that's the two ways that you'll see this. Yep.
So will we potentially have to go through the task of doing proofs?
Not with this. As we move forward, yes, but not right now.
No, on the quiz.
On the quiz, no. Probably test, but not on the quiz. Yeah. They're like the are they similar, if so, why kind of a thing. So like a one, like we did with side, angle, side, to proving that they're congruent. You do that similar to proving that they're similar, just not in a full out proof. Yeah. You're welcome. Okay, so the scale factor is you can get the scale factor if the two polygons are similar, and the way we find it, it's the ratio of the corresponding sides of the two polygons. This should be in us. Two similar polygons. So it will say find the scale factor of, and it will usually tell you an order. So if it says find the scale factor of ABC to, this would be triangle ABC, to triangle DEF. In this case, they are all the same. So it doesn't matter what side I put with what side. It would be 3 to 6. And as you move around, it should always be that same ratio. So it doesn't necessarily start that same ratio, but when we simplify it, it would always result in the same simplified fraction, which is the scale factor. So if I ask for the scale factor of ABC to DEF, it would be 1 over 2 or 1 to 2, like that, with a colon in between. You could write it either way. If I said find the scale factor of DEF to ABC, however, now that order is reversed, and this would be a 2 to 1. So the order that it gives you is important if it gives you an order. If it just says scale factor, then I would have taken either of those answers. But if it says specifically the left to the right or ABC to EFD, then it's important the order that you give that scale factor. And it will always be a simplified fraction. So even though it started as that 3/6, you would have to reduce it. All right, example 1 says for A, find the scale factor of A, B, C, D to M, N, O, P. So again, the orders here is important. A, B, C, D is the one on the left. M, N, O, P is the one on the right. So the A, B would match the Y. The 4 would match the X. The 14 would match the Z. And the 10 would match the 8. They will always give you at least one full ratio where there are values. Otherwise, you can't find the scale factor. So which of those ratios has an actual value for both? Nick?
The 12 and the Y.
Well, no, you... And,
The 10 and the 8.
good, the 10 and the 8. So my scale factor would be, if I went from left to right, because that's the order here, A, B, C, D to M, N, O, P, would be 10 to 8, which reduces to... Oh, good. I'm glad that happened. You want to keep it as an improper, so it stays 5 to 4. Okay, so don't put it in a mixed number. It would stay 5 to 4. And again, it could be 5 over 4 like that, or it could be 5 to 4. And in this case, if you gave me 4 to 5, it would be wrong. So you have to pay attention to the order that they asked for it. So then it says find X, Y, and Z. So every single ratio should equal 5 to 4. Which means if I want to find X and X matches the 4, that I can say 5 over 4 equals 4 over X. So I went left to right on the initial scale factor, which means I have to go left to right on the other ratios. And then from here, we can cross multiply. I get 5X equals 16. Divide both sides by 5, and X equals 16 over 5. This time, you can put that in a mixed number. That would be 3 1/5. So I would take either answer. Because it's an actual side length, you can put it into mixed number form. So this is 16 over 5 or 3 1/5. Then I'm going to repeat that process with the Y. So 5 over 4 would equal 12 goes with Y. 12 is in the left, Y is on the right, so I put it in that order. And then cross multiply again. 5Y would equal 48. And Y would equal 48 over 5 or 9 3/5. Questions so far? Yeah.
Wait, so to find the, I guess the opposite, like 4 to X and 12 to Y, you'll multiply by the reciprocal.
You can. I just cross multiply, but you can.
Okay.
Yeah. Because it's always going to be a ratio on either side, so you're always going to have a proportion, so I think it's easier to cross multiply, but you could do whatever. I'm gonna repeat what we just did again because we're gonna find Z. So Z is in the bottom, right? Z matches up with 14. So the scale factor from left to right was 5 over 4. And that would equal 14 over Z. So left to right and left to right, and then I cross multiply. 5 times Z equals 4 times 14, or 5Z equals 56. Divide both sides by 5. And Z equals 56 over 5, or 11 1/5.
So how do you know that the scale factor is 5 over 4?
Because the one ratio, they gave me one complete ratio that both had values, 10 and 8, and then we reduced it. So you got to find the scale factor first and then set it equal to what you're missing. So this was 56 fifths or 11 1/5.
Are we gonna have to find the scale factor?
Yep, that was the first question. All right, so C says find the perimeter of each. How do we find the perimeter of a quadrilateral or any shape? Add up all the sides, right? So if I add 12 and 4, that's 16. Okay, that was 16 plus the 14 from the bottom, and we've got 30 plus the 10, and we've got 40. So the perimeter of A, B, C, D is 40. And then we've got to add the perimeter of all the other ones. So I'm going to go back to before they were mixed numbers. I would get 8 plus 16 over 5 plus 48 over 5 plus 56 over 5. They are fractions, but at least they all have the same denominator. So I'm going to change 8 to be 40 over 5. And then add 40 plus 16 is 56. 56 plus 48 is 104 plus 56 is 160 over 5. All right, this is 32. 160 divided by 5 is 32. Okay, so then the perimeter of MNOP is 32. And what's the ratio of the perimeters? Good. 40 over 32 would become 5 to 4. So what do we notice about the ratio of the perimeters and the scale factor?
They're the same.
They're the same. So that is always going to be true. The ratio, your scale factor will be equal to any ratio of the corresponding sides. It will also be equal to the ratio of the perimeters. Okay, so scale factor would equal any of the corresponding sides ratio. And also the ratio of the perimeters. Because you're in geometry, right? That's what we do. So having known that, before we went through all the work of finding 32, if I had found the 40 being the perimeter of the first one, I could have said 5 over 4 equals 40 over x, and I could have solved that proportion to get the 32. Okay?
Why didn't you tell us that?
Because you had to discover it.
It's already been discovered.
Yeah, I know. That was so much more fun. All right, so the corresponding lengths in similar polygons is basically what we just said. If two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygons, and also what we just discovered, which was the perimeter, which is, you're going to see that. Let's look at the theorem. It's going to come up in 2 seconds. All right, so example 2 says, in the diagram, triangle TPR is similar to triangle XPZ. Find the length of the altitude of PS. So is the altitude would the altitude be a part of your triangle? It's not a side, but is it a part of your triangle? Yes. So can we use the scale factor the same way? Yes. So I'm going to find the scale factor of TPR to XPZ, which would be this whole side being 12, this whole side being...
12, 18.
All right, let's try that. 12 to 16 reduces to... What goes in about 12 and 16?
4.
4. So this is
3/4.
3/4. Okay. That would be the scale factor, which would be the scale factor of, which would be the ratio of the perimeters, which is the ratio of also any length inside the triangle, which means the altitudes. So 3 to 4, hang on, would equal x over 20. Thank you. And then you can either cross multiply, or actually this got multiplied times 5, so I can use that shortcut to get the other altitude to be 15.
Wait, what did you do?
Because 4 times 5 gives you 20, you could do 3 times 5.
And then you have to cross.
You don't have to cross multiply. If you did cross multiply, you would get it that way. So you could do it either way, but
That's really easy.
how do I get the x to the 20?
Over 20.
Because I went scale factor from left triangle to right triangle, right? Then I simplified it. That's where the 3/4 comes from. So then the missing altitude is on the left. So I go left, which is the x, over right, which is the 20. So left to right scale factor equals left to right altitudes, or left to right sides if you were looking for a side length. If you went right to left, 16 over 12, it would have been 4 over 3. Then it can be 20 over x. But whatever pattern you do with your scale factor, you have to keep that pattern when you set up the other one. Yep. All right, this is what we already talked about too. This is the perimeters of the similar polygons. So this is the first theorem. You'll almost never, I don't think you'll ever use this in a proof, but that is its name, okay? It says if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So this is what we discovered together on that first example. If I were to take and find the scale factor of KLMN to PQRS, then any individual side length ratio would also equal the same, and the perimeter, which is what this whole thing is, this is the perimeter of the first one over the perimeter of the second. It would also reduce to be the same thing. Okay, and then we take it a step further and say areas. Because areas are the product of two measurements, you actually take your ratio and you square it to get the ratio of the areas. So if two polygons are similar, the ratio of their areas is equal to the squares of the ratio of their corresponding side lengths. So if I had said that this ratio, let's just say it was 1 to 3, if the scale factor or the ratio of the sides or the ratio of the perimeters is 1 to 3, then the ratio of the areas would be that squared. So I'd square the top, square the bottom, and I'd get 1/9. If it was, let's just say it was like 2/3, that would be the scale factor, the ratio of the sides, the ratio of the perimeters, all of those would be the same. What would be the ratio of the areas?
4/9.
Good. So you square both, which would be 4/9. Questions? So area not the same, area you have to square. All right, last question. In the diagram, GHJK is similar to LMNP. Find the area of LMNP. How do I do it?
So we already have the scale factor.
We don't have the scale factor yet, but we can find it, right? What's the scale factor? So and it didn't give you a specific, like order doesn't really matter here. You could do 3 to 1 or you could do 1 to 3 as long as you follow that same order when you're setting up the areas. So if I do left to right, I would get 7/21, which would be what?
So
1/3. That's the ratio of the sides, the scale factor to the perimeter. What would be the ratio of the areas? 1/9, because you'd square both. Then I'm given the area of the smaller one, 84. So 1 to 9 should equal 84 over x. And then I just cross multiply. So 84 times 9, 756, and it would be meters squared. If I did it in reverse, if I did 3 to 1, so I went right to left, then I would have to square them both to get the areas. It would be 9 to 1, but then I would set it equal to x over 84. So the order doesn't matter in the beginning, but whatever order you establish from the beginning, you have to be careful when you go to set up the second ratio. Yeah?
Did you just multiply 9 times 84 in your head?
Yes? Oh, did I multiply it in my head? No, I worked it out.
as you can see on the screen,
I did it here.